Hi, welcome to Chemical Equilibrium. My name is Dr. English. Today we're going to be talking about Le Chatelier's principle with a focus on changes in pressure. Specifically, we're going to look at pressure changes in equilibrium, changes in pressure, a walkthrough practice problem, and then some Regents practice questions in the end. Pressure changes in equilibrium. Changes in pressure affect equilibrium systems containing gases only. Now remember, we're New York State. This is applying to the New York State Regents exam. There might be a difference of opinion depending on where you are from, in the world. But we're just going to leave it at that this is based off the New York State Regents chemistry curriculum. An increase in pressure, so we're increasing pressure, results in decreasing volume. So again, an increase in pressure results in a decrease in volume. This will shift the equilibrium in the direction that produces the smallest number of cumulative moles. So what do we mean by cumulative moles? That means we're going to add up the coefficients from a balanced chemical equation comparing total moles of reactants to total moles of products. So an increase in pressure, decrease in volume, smaller number of moles. That's what we're looking for. A decrease in pressure, so now we're decreasing the pressure, therefore our volume is increasing, causes a shift in equilibrium in the direction that produces the largest number of cumulative moles. And again, that means you're going to add up the coefficients from a balanced chemical equation and compare the total number of moles of reactants to total number of moles of products. You want to shift to the side that has the greater number of total moles when you're decreasing the pressure and increasing the volume because more space can be occupied by that gas. Let's look at an example. We have nitrogen plus hydrogen gives us ammonia. This is my left and this is my right. The stress on the situation is that we are increasing pressure. If we are increasing pressure, we want to go to the side of the balanced chemical equation that's going to have the least amount of moles. So we add up an assumed 1 mole right here with 3 moles right here, which gives us a total number of 4 moles, and we compare that to our products, which only occupies 2 moles. So an increase in pressure is going to result in a right shift, where the reactants are going to combine together to make more products. As a result, pressure increase is relieved, the amount of N2 will decrease, the amount of H2 will decrease, and overall, our amount of ammonia will increase. So if we wanted to do something to this closed system to make more ammonia, we would increase the pressure, thereby decreasing the volume, so that more moles of ammonia could be produced. Pressure changes in equilibrium. Pressure will only affect the equilibrium of a chemical reaction if all the reactants and products are in the gas phase. If a compound in the reaction is in either the liquid or the solid phase, a change in pressure will not affect the equilibrium. If a cumulative number of moles of molecules in the gas phase are equal, in other words, we add up the number of moles on the reactant side and the number of moles on the product side, and it turns out that the number is the same, a change in pressure will not affect the equilibrium, and you need to watch out for this one. So if you're looking at a situation where pressure is being considered, you need to make sure that you total up the number of moles on the reactant side, the product side, and compare the two. Let's do some practice. I have O3 and O2, right? This is my left and this is my right. The stress here is that I'm adding pressure. If I'm adding pressure, I want to go to the side where I have the least amount of moles. So if I look at the coefficients here, I have a 2 here and I have a 3 here. So if I add pressure, I want to shift my point of equilibrium towards the reactant side and make more ozone, O3. So the response here is a left shift. The amount of O3 is going to increase, and the amount of O2, my oxygen, is going to decrease because I've added pressure, I've decreased the volume, I want to go to the side with the least amount of moles. Let's look at another example. In this situation, the stress is to remove the pressure. So I want to go to the side with more moles. So this is my left, this is my right. If I look at my coefficients, again, I have 2 and I have 3. So I want to shift my point of equilibrium over to the side that's going to produce more moles of gas. Therefore, I'm going to produce more oxygen. So as a response to this stress, this is going to be a right shift. As I'm going to favor the formation of products, my amount of ozone, O3, is going to decrease, and the amount of oxygen, O2, is going to increase. Because I'm removing the pressure, I'm increasing the volume, I want to produce more moles of gas. Let's look at another example. PCl5 in a reversible reaction with PCl3 and Cl2. So this is my left and this is my right. The situation here is that I'm adding pressure. As soon as I'm adding pressure, I'm decreasing volume, which means I want to go to the side with the least amount of moles. So I have 1 mole here, and I have 1 mole here and 1 mole here. So if I add the total number of moles together on the product side, that's 2 moles of product compared to 1 mole of reactant. So if I'm adding more pressure to the system and I'm decreasing the amount of volume, I'm going to shift my point of equilibrium to favor the formation of reactants. So my response here is a left shift as I favor the formation of reactants. My PCl5 is going to increase, my PCl3 is going to decrease, and my Cl2 will also decrease. Let's look at another example. Again, we have PCl5, PCl3, and Cl2. This is my left, and this is my right. I know from before that I have 1 mole of reactants total, and my total number of moles on my product side is 2. In this case, I'm removing pressure. I'm increasing volume. So I want to go to the side that has more moles of gas. That means my point of equilibrium is going to shift to favor products. It's going to shift to the right. So this is going to be a right shift to favor the formation of products and more moles of gas. My PCl5 will decrease, and my PCl3 will increase, and my Cl2 will increase. Let's try some Regents practice questions. Given the equilibrium reaction, 4HCl plus O2 yields 2Cl2 plus 2H2O. If the pressure on a system has increased, the concentration of Cl2 will, so what I'd like you to do is stop, reread the question, choose an answer, and we'll see how you did. Welcome back. Let's see how you did. So the first thing that I'm always going to do is say this is my left and this is my right. So if the pressure on the system is increased, okay, everything's in the gaseous state. So I know this is a pressure question. I'm going to add up the total amount of moles on my reactant side, which is 5, because there's an assumed 1 right there. And I'm going to add up the total number of moles on my product side, which is 4, because of the 2 here and the 2 here. So if the pressure on the system is increased, okay, we're increasing the pressure. That means I'm going to shift this point of equilibrium over to the side with the least amount of moles because I'm increasing pressure, decreasing volume. The concentration of Cl2 will, here's Cl2 right here. By increasing the pressure on the system, we are going to the side with the least amount of moles. Cl2 is on the side with the least amount of moles. Therefore, this will ultimately increase along with H2O increasing, HCl decreasing, and O2 decreasing. Therefore, the concentration of Cl2 is going to increase. Let's look at another example. Given the reaction, A plus B yields AB. As the pressure decreases at a constant temperature, the rate of the forward reaction will, I'd like you to stop, reread the question, select an answer, and let's see how you did. Welcome back. Let's see how you did. So again, the first thing I'm always going to do is say this is my left and this is my right. And then I'm going to count up the total number of moles on my reactant side and product side. So the total number of moles on my reactant side is 2, and the total number of moles on my product side is 1. So we're decreasing the pressure and therefore increasing the volume. If that's the case, where pressure is decreased and volume is increased, I know that I am going to move my point of equilibrium over to the reactant side in favor of the formation of reactants. I'm going to shift in that direction. So as a result, the rate of the forward reaction, well, we know the forward reaction is going from A plus B to forming AB. We're not doing that now. We're going in reverse and forming more of A and B. So the rate of the forward reaction, if pressure is decreased, means that the forward reaction itself is going to decrease. So what did you learn? We talked about pressure and changes in equilibrium. We talked about how equilibrium is affected by changes in pressure. We did some walkthrough practice, and then you did some Regents practice questions on your own. Need more help? Feel free to contact me. Have a great day.